Hi, in this video, we will be learning some of the types of patterns and some of its examples. First, the logic patterns. Logic patterns is all about classifying things. For example, comes before enumeration. Being able to tell which things are blocks and which are not precedes learning to count blocks. One kind of logic pattern deals with the characteristics of various objects, while another deals with order. These logic patterns are seen on aptitude tests, in which takers are shown a sequence of pictures and asked to select which figure comes next among several choices. This definition on logic patterns are proposed by Nocon and Nocon, published on 2018. Logical reasoning tests, also known as critical reasoning tests, are designed to assess a candidate's ability at skills such as how to interpret patterns, number sequences, or the relationships between shapes. They have much in common with abstract reasoning, diagrammatic reasoning, and inductive reasoning tests. Here are some examples of logic pattern tests from marynotes.com. For this one, which circle would continue the sequence? As you can see, there are three given sets of circles, and our challenge is to identify which would be the fourth circle among the choices in A, B, C, and D. Now, let us try to examine. All of the three sets of circles have a smaller circle inside it, and the smallest circle which is shaded black. For the first given, as you can see, the smaller circle is attached to the right side of the bigger circle, while the smaller circle on the second bigger circle is on the lowest part or in the bottom. And the smaller circle on the third one is on the left side. Now, if you're going to observe, you can see that the smaller circle is actually moving towards a clockwise positioning. So from here, coming lower and then going to the left. Now, what do you think would the smaller circle of the fourth one look like? So let's try to create a model. I will make a circle. And since the first one is here, the second one goes right here, and the third one is here, then the fourth one would be up here. So the smaller circle on the fourth one should be up here. And as you can see, among the choices, only B, C, and D falls in the category correctly. So immediately, A will be disqualified. Now, for the smallest circle, which is shaded black, for the first circle, you can see that it is on the right side, or the right part of the circle, because circles do not have a side, does not have side. And then, the shaded circle on the second circle, bigger circle, is on top, while the shaded circle on the third set of circles is on the left side, or the left part of the circle, bigger circle. Now, if you can observe, the shaded circle is moving in a counterclockwise position. So from here, it goes up, and then it goes down to the left side, or the left part of the circle. I keep on mentioning side. Now, where do you think would be the fourth shaded circle be? So since it comes from here, going up, and then going down on the left part, then most probably, the shaded circle for the fourth one will be right here. Okay, it should be shaded. Now, which among B, C, and D is correctly describing our answer? Yes, it's letter C. Very good. And now we have a second logic pattern test example coming from meritnotes.com. For this one, we will try to check which is the missing circle. As you can see, there is an erratum. This should be circle. Okay. Now, you have here your given sets, and then we are looking for the ninth circle which will satisfy the given conditions on the given 8. Now, let us try to check. Okay. You can see that all of the circles have two sets of smaller circles inside it, and we have a minute hand just like in a clock. Now, let's try to check first the shaded circle. Okay, just like the previous example, you can see that the shaded circle are moving in a particular direction. Like for this one, it's on the topmost part of the circle. Then it moves on the second circle, it moves downwards in a clockwise position. And then for the third one, it's on the bottom. Okay, clockwise position. While the unshaded circle, you can see that for the first one, it's on the left side or in the left part of the circle. Then it moves downwards, but in a counterclockwise motion, and it goes up, and now it is on the right portion. Now, we can now see that the two circles inside the bigger circles are moving on separate directions. While the minute hand, you can see that for the first one, it points upwards, while the second one, it moves downwards in a clockwise position, but it only moves at about 45 degrees, and it moves another 45 degrees so that the minute hand now points on the right part of the circle. Now, supposedly, it follows the same motion or directions on the second set. Then let's try to see. We have the shaded circle inside the first circle on the right part. Then it moves clockwise, it's now in the bottom. Then it moves further clockwise, then it's now on the left part. While the unshaded circle, since the shaded is in clockwise position, then the unshaded one would be on a counterclockwise. So for the first one, it is down below. Then it moves to the right, and then it moves upwards, and it is now here. Now, how about the minute hand? First, the minute hand points right here in 1 o'clock. Now, it moves such that it's already in 3 o'clock. And now, this one has already moved to the 5 o'clock. It's pointing to the 5 o'clock. So, it's just the same pattern with the first set of circles. Now, let us try to visualize the last set. Okay, let me draw a circle right here. Okay, again, this is not a perfect circle, so just bear with me. Okay, for the first set, you can see that the shaded circle is already on the bottom. Now, it moves clockwise so that the shaded circle is now on the left part. Now, where do you think would the shaded circle be already? So, it is on the top part. So, I will draw a shaded circle here. Okay. Shaded circle. I'm sorry if this is not perfect. Okay. So that's my shaded circle. Now let's try to see among the 6 choices which satisfies the first phase of the circle. So A, yes, it's correct. B does not. Okay, sorry B, I will crush you out. C does not. And letter D does not. As for now, we have A, E, and F satisfying the first condition. Now, let us try to see the movement of the unshaded circle. For the first one, the unshaded circle is on the right part of the circle. Then for the second one, it moves upwards. Now, for the third circle, where do you think would the unshaded circle be? So since it is moving in a counterclockwise direction and the second unshaded circle is already on top, then the third one would be on, yes, it will be on the left part. So it would look like this. Now, let us try to see among the remaining choices A, E, and F, which of these satisfy the given condition. We have letter A, it's correct. Letter E, it's also correct. While F, it's now disqualified. Okay. Now, we are down to the last object, which is the minute hand. Now, for the first one, the minute hand points on the 3 o'clock, while the second minute hand points on the 5 o'clock. Then where do you think would the third minute hand be pointing? Since for the first one is 3, the second one is 4, then the third one will be pointing on the 6 o'clock. Yes, that way. Now, which do you think in A and E satisfies the given condition? Very well, it's a letter A. So the missing circle for this set is letter A. You are correct. And now we are on the second type of patterns, which is the number patterns. The number patterns are patterns in which a list of numbers follows a certain sequence. Generally, the patterns establish the relationship between two numbers. It is also known as the sequences of series in numbers. In order to solve the problems on the number pattern, first, we must understand the rule being followed in the pattern. There are different types of number patterns in mathematics. One of these is an arithmetic sequence. An arithmetic sequence is a sequence of numbers in which the next terms are obtained by adding a common constant, also known as the common difference. Here is an example. We have 23, 29, 35, and 41. How do we get to obtain the next terms? Now, as you can see, there is a plus 6 above 23. Now, what does this mean? This positive 6 is called the common difference. This is added to each of the succeeding terms so that we will be able to identify which number comes next in the sequence. In this case, we have 23 plus 6, it becomes 29. For us to get the next term, which is 35, we need to add another positive 6. And to get to the next term, 35 must be added positive 6 to get 41. And so on. To get the next terms on this sequence, you will need to continuously add positive 6. Now, in this arithmetic sequence, you will see that the numbers are in increasing order, meaning the number becomes higher as it goes on because the common difference is positive. How about the next example? We have 59, 50, 41, and 32. As you can see, this arithmetic sequence is in decreasing order. Why? It's because the common difference is a negative number. In this case, what number must be subtracted from 59 so that you will get 50? Yes, it is negative 9. So, you will just have to add negative 9 on the succeeding terms so that you will be able to find the next terms in the arithmetic sequence. So, we have 59 plus negative 9, or simply minus 9, you get 50. And then we have minus 9 again to get 41, minus 9 again to get 32, and so on. If you wish to identify the next terms in this arithmetic sequence, you will have to continuously add negative 9 to get the next terms. The next type of number patterns is called the geometric sequence. The geometric sequence is a type of sequence in which the next succeeding terms can be identified by multiplying a constant number which is called the common ratio. Here's an example. We have 5, 20, 80, and 160. Now, in order for you to get the next term, you will have to divide the second term by the first term, and then the answer will be your common ratio. In this case, 20 divided by 5 is positive 4. Therefore, positive 4 is the common ratio. Now, what would be the next terms? We have 5 times 4 is 20. To get the next term, you will have 20 times 4, and then you will get 80. Then, 80 times 4, you will get 160, and so on. In this case, this geometric sequence has a common ratio of 4. Here's another example. We have 3, negative 12, 48, and negative 192. For you to get the next term, the common ratio, you will have to divide negative 12 by 3. And the answer is negative 4. So that means 3 times negative 4, you got negative 12. Negative 12 times negative 4, the answer is positive 48, since multiplying integers with the same sign is equal to positive. Then we have 48 times negative 4 is equal to negative 192, and so on. Now, if you can observe, the first example have all of its terms having the same sign, which is all positive, while the second example have an alternating signs. In this case, we have positive 3, negative 12, positive 48, and negative 192. What does this imply? Now, once you can observe that in a geometric sequence, all of its signs are the same, then the common ratio is a positive number. But if the terms in a geometric sequence have an alternating signs, then the common ratio is a negative number. That is just one thing that you will have to remember when dealing with geometric sequences. The next type of number patterns are the square numbers. The square numbers can be determined by multiplying an integer by itself. Here are examples. We have 1, 4, 9, 16, 25, and 36. How did you get these numbers? All you have to do is just to multiply the counting numbers by itself. And we have 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and so on. Next are the cube numbers. This can be identified by multiplying an integer by itself twice. That means you will have to multiply the same number in a set of 3. Here are examples. We have 1, 8, 27, 64, 125, 216, and so on. We can get these numbers by multiplying the same number 3 times. We have 1 times 1 times 1 equals 1. 2 times 2 times 2 equals 8. 3 times 3 times 3 equals 27. 4 times 4 times 4 equals 64. 5 times 5 times 5 equals 125. And 6 times 6 times 6 equals 216. And so on. Up next are the triangular numbers. These are numbers that can be represented by a pattern of dots arranged in an equilateral triangle. You can see these numbers on the screen. We have 1, 3, 6, 10, 15, 21, and so on. As you can see, these dots can form an equilateral triangle such that the same numbers of dots can be seen on each side. And finally, the last type of number patterns are the Fibonacci numbers. These numbers is a series of numbers wherein the next number can be found by adding up the two numbers before it. These are the numbers. We have 0, 1, 1, 2, 3, 5, 8, and 13. How did you get these numbers? You can either start at 0 or 1, but in this case, you are starting with 0. So you have 0, the next one is 1, and then add 0 and 1, you will get 1. To get the next term, add 1 and 1, and then you get 2. Then add 1 and 2, you get 3. Add 2 and 3, you get 5. Add 3 and 5, then you will get the next, which is 8. And to get the next one, add 5 and 8, which is 13. And so on. And now, we are down to the geometric patterns. A geometric pattern is a motif or design that depicts abstract shapes like lines, polygons, and circles, and typically repeats like a wallpaper. Visual patterns are observed in nature and in art. This is according to Nokan and Nokon on 2018. In art, patterns present objects in a consistent, irregular manner. They appear in paintings, drawings, tapestries, wallpapers, tilings, and carpets. A pattern does not need to repeat exactly if it provides a way of organizing the artwork. Patterns in nature are often chaotic. That means it can be very disturbing, or it has plenty of details that can be a little bit difficult to stare at in the eyes. Examples of pattern in natures include symmetries, spirals, tilings, stripes, and fractional design. Now we are down to the word patterns, the last type of patterns. Word patterns can also be found in language like the morphological rules in pluralizing nouns or conjugating verbs for tense, as well as the metrical rules of poetry. The focus here is patterns in form and in syntax, which lead directly to the study of language in general and digital communication. This is according to Nokon and Nokon in 2018. Here are several relationships between pairs of words are possible. This is based on the article by https://www.assessmenttraining.com/blogs/tips-to-pass-an-analogies-test. The first type of word patterns are the antonyms. The antonyms are those words that have opposite in meanings. Examples are beautiful is to ugly and the good is to bad. So those words with opposite meanings are called antonyms. Words that have similar meanings are called the synonyms. Examples are buy or purchase, big and huge, small or tiny, clear or clean, fat or bulgy, and so on. Descriptive. These are word patterns that describes the other word. So you are just simply giving a description on a particular object. For example, blue is an ocean. Something tiny, it is a sand. Something green, these are the leaves. Something expensive, a sports car, and so on. Another type of word patterns are the part to whole. One word is a part or a piece of the other. Example for this are, we have the head is part of the body, the lace is part of the shoe, the fingers are part of the hand, or the stomach is a part of the digestive system, and many more other examples. Then we have steps in a process. Like for example, when you are cooking, part of it is serving the food. And when you are cleaning, part of it is scrubbing the floor or the dishes that have plenty of grease. And also we have the cause and effect. Like for example, when there is fire, then there is scorching heat. And when there is blizzard, then it can be very freezy. Word patterns can also be in the form of the things and their functions, like the scissors are used for cutting, or the pencil or the pen can be used for writing, and many more. Then we have the relationship of an item to a category. One word names something that falls into the group named by the other. Like we have this. The lemonade is a type of a beverage, while Captain America is a superhero. Word patterns can also be in the form of implied relationships. In this one, these two words can actually have a relationship with each other. Examples are the clouds and the sun. These two things can be seen on the sky. And we have the bread and the butter. These two food items are commonly eaten during breakfast. And we have the symbol and what it represents. So if you're good at symbolism, then this is easy peasy for you. For example, we have the heart is the symbol of love, while the dove is the symbol of peace. I believe you can think of other things or objects that has a representation. So there you have it. I hope that you learned something on the different types of number patterns, word patterns, geometric patterns, logic patterns, and etc. I hope that the next time that you experience or encounter these challenges, you will be able to find it easy and all will be very good and well for you. This has been your teacher. Thank you very much for listening and watching.